Does everybody feel better about the homework? How that works, when it's due, all that kind of stuff? All right. You should be working on something kind of continuously. Unless your life is like mine when I was in school, then you work on it whenever you actually have time. Yes?
For the homework, was it due today?
Yeah, what's due today? Anything? Not a damn thing. So last Tuesday, we didn't really get into 2-1 all the way. So here's how the soft due date works. The day that I finished lecturing over a section, so like last Thursday, I finished section 2-1. We do. Which means this Thursday, so 2 classes later, a week later, you should be ready to turn it in. If you're not, it's not the end of the world because it's not late until you give it to me after the test. Does that make sense?
Yeah.
Soft due date helps you know if you're on track. Hard due date is because we all need that as humans, right? Did I tell you that one semester I didn't make homework due? And everybody bombed the first test in, so never. Yes?
Can you like upload pictures of homework and on this, or would you rather
So I want you to really hear me. The pandemic was so bad for so many reasons, and one of them was grading homework online. Right? That sucked so bad. I had this, real quick, I had the mouse, which was insane. So like, when we went to the pandemic and we were doing online teaching, I was trying to write with my mouse. You see how I write with normal stuff? So you can only imagine. So then I got this thing that was like a pen that was a mouse. And it sucked bad. And then I got this tablet that you could just write on. It didn't really write, you know what I mean? But it was basically like, and it was great. It didn't make my writing better, but it didn't make it worse. You with me? No, don't do that. Print that bad boy out, turn it in right there, beginning of every class. If you have any homework you're done, just turn it in, right? And every time you get a section done, turn it in. Okay.
And is all the homework from the book?
Huh?
Is all the homework from the book?
Hell yeah. And what problems do you have to do? Do you have to do all the problems? Please give me back. Here we go. This is why the homework timeline sheet exists. It tells you when we're going to be doing what, and it tells you which problems to do, right? So like section 2-1, you only have to do 3 through 30, every third one. 3, 6, 9, 12. Is that cool? If you do more, it's great. You get more practice. I'm not gonna be upset about that. At the same time, I want to respect your time. Don't think you have to do all of it wholly. Is everybody really with me on that? It's always weird to me when it's the 5th week and somebody's like, how does homework work again? Is it due? Like, what's going on? Okay. Everybody else is okay. So let's do this. Let me write down the quiz information so it's officially caught in the record. So future Jeff can remind himself what he said the quiz is going to be on. So let's have a quiz next Tuesday. And it's going to be 2-1, 2-2. Nice and simple. First quiz. I think, shoot, now I gotta go back. Has everybody got that? I gotta remind myself. Our first test is September 11th. And so this next Tuesday, oh shit, I don't know when things happen. I'm gonna try to give you one more quiz after that, but I'll let you know when it's gonna happen, when it's gonna be on. I try to do 2 quizzes before a test, because do you guys know you want more grades? Have you guys done enough college? Or some of you guys, this is your first time in college, so you don't know this. You want more grades. I had a class where the only grade, did I tell you about this class? The only grade was the oral final exam. It was my quantum mechanics class, and he put each of us in our own room. He gave us a problem and said, work on this, I'll be back. Are you guys with me? That was the only grade. Can you imagine the pressure? So the more grades, the less pressure for each thing, yes? So that's something for you to keep in mind as you become a teacher. You want to give your students low stakes stuff, meaning like group work stuff that you maybe don't even look at. And then of course, spread out the stakes. Don't have big, giant, that's why I hate the idea of a midterm. It's like this thing in the middle is supposed to give you all this anxiety. It's like, no, tests already do that enough on their own. But you spread it out, okay. Any questions on that stuff? Okay. Let me do one thing real quick. I'm going to try to wake that monitor up. This is going to bug me. Have you tried turning it off? Now watch this. That's going to turn on, and this one's not going to work. Let's see. Okay, that's on. See, I knew it. Shit. Now that's the only one that's on. I love you guys. So how's everybody doing? Yeah. Oh. Okay, what just happened is I pushed the off button. It's currently off. So I'm just going to leave it the way. Okay. This room is possessed. Okay. Let's see if this works. Okay, good. I'm happy. I'm fine. All right, guys. Are you guys really okay? I could be a little bit of a lot. I know. I'm sorry. But I like discussion. So please, dear God, don't hold back when you have questions. So what I want to get into is section 2.2. So there were some really good questions earlier from section 2.1, so hopefully section 2.1 is going well. So 2.2, let me kind of build our way into this a little bit. What does this symbol, this is going to be kind of silly. What does this symbol represent? Yeah, that's my attempt at writing the numeral 3, yes? So we very often, just talking about it very quickly, we say that's the number 3. But that's the numeral 3. A numeral is the symbol you use to identify the number. Are you guys with me? You understand? So if I was in a different civilization thousands of years ago, might they have used a different symbol for the idea of 3? Yes, in fact, the ancient Chinese civilization used that. So you can imagine 2 would have been this, yes? Now 10, thankfully, isn't 10 of those. 10 was its own shape. Are you guys with me? But the first 3, 1, 2, 3, were just 1 line, 2 lines, 3 lines. The Mayans would call 3 this. That's 3 for the Mayans. So we're going to get into representations of the idea of number. You with me? One reason you do that as teachers is if you're teaching very young kids, as you learn these other civilizations, you understand how the kid is feeling. Because they are learning our civilization's number system. They don't know it. So you're going to learn some stuff that you don't know. And part of that is so you can realize how they feel. Older kids, this is actually in some of the curriculum for them, is to learn other civilizations' number systems. So obviously you have to know about them also. All right. So do you guys know anything about any other number system besides ours? Say again? Kick-ass. That's all. I was hoping somebody would say that because that's the most immediate. You guys know Roman numerals, and you actually use them in English a lot. When do you use them in English? Yeah. What is it called when you're making the outline? Right. So you guys know like the first 10 normally. Yes. All right, so we'll get into Roman numerals and we'll push it beyond what you know. Okay, so remind me, numeral versus number. Which one is the idea of how many? Number. And how do I represent that idea with a symbol? Numeral. Kick ass. Kick ass. So here are some. Before we get into the nifty different symbols and so forth, we have to live in the beautiful world of definitions. So we have what we just talked about, number versus numeral. Number is the idea. Numeral is the symbol we use. Does anyone write their 4 a different way, by the way, than what I do? Some of you guys are like, yeah, I write it that way, but just better. Does anyone write their 4, is it like this? Does anyone write their 4 like that? Thank God, because it ends up looking like a 9. And then I'm like, oh my God, what did they mean? Okay. Very quick, everybody can see that's 4 dots, yes? So if I just said, how many dots is this? How long will it take you to tell me? Can you just tell me? You have to count it, right? Are you with me? So it's interesting. There's no overriding reason why there should only be if I put 1 dot, obviously you don't have to count the damn thing. 2, you don't have 3, you don't 4, you don't have 5, you don't have to count, especially if it's in this symbology of a die. And then 6 isn't bad, especially if it's 1, 2, 3, 4, 5, 6. If it's organized, if it's disorganized, you have to stop and count. Are you guys with me? What's really cool for you guys, if you want to, you can get a little deeper into how do we see things, how do we count things? How does our brain work with something where I don't even have to count? What's the limit of that? You guys all with me? Some people can see 7 things disorganized and they know it's 7 just because they were born with their brain hardwired to be able to do that. Then you got has anyone ever seen the movie Rain Man? He dropped the matches and he's 247. No? Has anyone ever heard of the movie Rain Man? Okay. It's again not a prerequisite to take the courses to watch that movie. So 3 kind of places that we run into numbers the most. The most basic way we use numbers is as cardinal numbers. And of course, what would you say if I just asked you, what's the most basic thing we do with numbers? The most basic thing. Count. That's what cardinal numbers are. It's the number of elements in a set, right? It's actually the words we use to represent those things. So this represents number of elements in a set. So this would be the cardinal number that represents the number of dots I put there. So that the idea of it being a cardinal number, that's the one we use it for the most. Is there another way we use numbers? When you fill out a job application, what kind of numbers do you have to put down? Student ID, is that counting something? Representing something. What about your social security number? You have to put down your address. Are those really counting? Do you have to put down your zip code? Is that counting something? I live in 91941. Does that mean I have 91,941 somethings? If I do, I'm where are they and where are they? I guess kind of. Do you see how it's fundamentally different from cardinal number? We just have numbers that act as names. So screen number, anybody play sports? Do you have a jersey number? Yes? What number are you? Out of curiosity.
Oh.
I'm sorry, you. What number are you?
26.
26, okay. Real quick, side note. I was teaching statistics, and there's an idea of if I add 2 jersey numbers together, does the answer actually mean something? No. But I had 3 people that were on the basketball team. One was a number 4, one was 7. And I'm like, if you add 4 and 7, and they're like, oh, you get Michelle, because she was number 11. I was like, shit. So in case you're curious, 4 plus 7 equals Michelle. You're welcome. I'm sorry, you guys with me. So the other way to use numbers, one of the main other ways to use numbers is as identification. Literally just another name for us. So screen number, jersey number, blah, 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 blah. And then finally, this one's sort of like cardinal numbers, but it's called ordinal numbers. What do you think the root word is for that? What's the root word for that? What's it related to? Order. So it's like being 7th place in a race or something, right? So this one deals with ordering things. So if I go to a deli, has anyone ever been to Panera? They used to give you like a little number on a stand. Do you remember those numbers were in order? Like I walked in, first person in there, because I'm going to grade some papers, and I got there when they opened, and they gave me 157. I'll never forget this because, side note, that's half of 314, which is a representation of pi. So I kind of geeked out, and I'm like, are you okay? But I was number 157, and I was the first person there. So would that act as a cardinal number? No. Is it more like an identification? Yes. But is it even more like an ordinal number? It had me in order. If somebody else came in, they gave them the number 7. Then behind the scenes, they know 157 and then 7. So did the numbers have to be in order for them to actually keep us in order? No. So they were sort of like identification numbers, but they kept us in order. Are you guys in all with me? I'm spending way too much time. This is not that big of a deal. So obviously, real quick, just to kind of really hammer this home, what idea do these three sets embody? You can do it, Jeff. Just make something up. There you go, buddy. I like this. What idea do those embody? What numerical idea do those embody? No. Like each one of them has something in common. What do they have in common?
Sets of three.
They're sets of three. So those represent the idea of number. They each have three things. Every civilization that ever existed had to come up with a way to represent that idea. We very quickly understood that idea, yes? Three. When that came up, I need 3 rocks so I can stack them up so I can have this, that. So understanding we needed a way to represent the idea of number came quickly for us. And do you guys remember what I told you in terms of what children learn first when they're about to learn how to count? What do they learn first? Kind of independent. It's actually independent of how we use it. What do they learn first when we're about to completely start them being able to read? What do they first learn? Yeah. Alphabet. So they learn the chant, right? Okay. Same thing with numbers. 1, 2, 3, 4. They learn how to say that. They don't have a connection to anything else. And of course, part of your job, if you're lucky enough to get that, if that's what you want, is to connect that chant with actual physical things. Yes, okay. Blah, 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 blah. Oh yeah, okay. I already talked about some of this. Fantastic. I think I talked about this. So real quick, if one set was this, sorry, and another set was this, what do you think this would represent? I don't think I've used that notation yet. If you had to guess, compared to everything we've just been talking about, what do you think that would represent? No, I appreciate that. That's not a bad idea. But what have we been talking about this entire time? The idea of numbers. So that means the number of things in it. So of course that would be, that's insane. The number of things in B, that would be 2. Why is 2 less than 3? How would you communicate that to somebody who doesn't even yet really understand what 2 and 3 are? When you're talking to them at that level, what are they probably already doing? What do they want to do all day? What do we want to do all day, to be honest? We're going to play around. We don't just play, right? So what are they doing? They're playing. So would they realize if they had some toys and they left and you took one away and they came back, would they notice? Does that mean that they counted the toys? But they understand the idea that the set of toys is smaller now, yes? So how would you explain to a student why 2 is less than 3? What's another way to say that same thing, but reference sets of objects? 2 represents which set? B, and 3 represents which set? And what would you say to them as a first level to get them to understand 2 is less than 3? How many things are in B? 2. Do they even need what could you ask them? You could ask them, which set has more? Yeah. Which set has more? Right? Here's one bag with 2 toys. Here's one bag with 3 toys. Which one has more? Yes? Do you understand? So even from that perspective, they might not even know the number 2 and 3, the idea of the number, the numeral 2 and 3. They might not understand any of that, but they understand one has more in it. Okay. So what does it really mean then when we say this? What we mean, yeah, go ahead, sorry.
2 is less than
Okay, so that's what that literally means. But that's because if I have a set of elements that is smaller than another set of elements, the numeral that represents the number of things in that set is less than the other. Now, look. The weird thing for us, and the weird thing for a lot of parents, and this is one reason why I don't like to go on Facebook. Parents will post, look what they're teaching my kid. You just carry the one and like, you understand that shit. The kids don't understand that at all. You have to build to that, correct? So a lot of what you're going to be doing is building. And the building you do is not going to necessarily look anything like what you and I do when we do a math problem. Why? Because they don't know everything we do, right? Are you guys all with me? All right, who plays sports? I know you do. You're number 26, right? Well, anybody else play any sports? Officially, unofficially, just play tennis and don't care whatever you play. What do you play? Tennis? All right, cool. What do you play? Soccer? You play some too or no?
I play tennis and basketball.
Do you, Julie? That was my two go-tos. Yeah. Yes. Softball. Same. Okay. Did you ever have to do something that didn't immediately tie to your game to get your game better? For example, do you do like weightlifting or stretches or something? Do you ever do that while you're playing? No, but that does help your game, correct? So this is, I don't know if this analogy is landing, but it's like balance. If you can balance better, so there's a lot of balance exercises. If you balance better, and then in tennis you do a lot of like this because you want to always, this is how you want to get to a ball, is you don't want to run into it like that. No. You're not ready then. You guys kind of see what I'm saying? So there's a lot of little things you do that don't feel like it's necessarily connected. So that's, I really want you guys with me. Parents don't understand the prep to get to what we do. And there's a lot of connections between what comes naturally to us and the symbols we use for that. And there's a lot of building. Oh, early. Okay. Okay, I like it. Oh yeah, that's kind of gross. Let's not do that. All right, so let's talk about this. So the bulk of section 2.2 is about numeration systems. Holy shit. So one already came up. Roman numerals. That is a numeration system. It's got rules how it works. I'm pretty sure I told you guys what our system's called. Our set of numbers. Set of numerals. Do you guys remember what they're called? Yes, Hindu Arabic. This is a really cool, I gotta find it, there's a really cool evolution of our number symbols over the numerals we use over the centuries. But we stole them. We didn't have to create them ourselves. We just kind of said, they look good, let's use those. So are you with me? So, what do you think is the most basic numeration system? For example, we're just having sheep. For some reason, I'm a sheep shepherd. See sheep coming in. How do I kind of count them off real quick without having the right numbers? What would I do? What's the quickest way? What's that song? Hey, mister. My bananas. You're all tally. Yes? So real quick. Something that came natural to us, if we were counting the number of sheep going by, we can go, there's a sheep, there's a sheep, there's a sheep, there's a sheep, right? There's a sheep, there's a sheep, there's a sheep. And now, that gets really horrific. Because later I can go back, but can I see very quickly how many? No. Like I said earlier, that's too many. Our brains aren't hardwired to know what that is. I have to actually count. Are you guys with me? So civilizations came up with this. Some civilizations actually used slightly different symbols, but they all meant the same thing. What was one immediate improvement that was made that we actually still use today in some situations? Yes?
Slashing everything.
Yeah! Eventually humans went, what the shit are we doing to ourselves? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, why is that easier to count? Because now visually, there's only 2 things there. They each represent 5. So I can tell there's 10 things. Whereas I don't even know how many, to be honest, I didn't 2, 4, 6, 8, holy shit, I love it. I didn't do that on purpose. So there's 10 here, but if I just glance at this, can you tell it's 10? I couldn't, so if you can, teach me, but I had to stop and count. Here, can you tell it's 10 really quickly, just glancing at it? Of course, because now we've grouped it. Now I only see 2 groups, 5 in each. 10. Are you guys coming? I know on one level this is silly. I mean, we live in a time on the shoulders of a lot of people that came before us that tried number systems. They sucked, not so good, they improved. Okay, better, but they still suck. Okay, improve over many centuries. And now here we are going, why don't you just use the number 10? Right? But what we're doing is we're investigating the way our civilizations came up with numbers, our numeration systems, is kind of mimicked by the way the students learn what numbers are and numerals and what they represent. Okay. So now we get to the first real official thing we're really responsible. The first numeration system you guys are going to be, because this you all know. You all know. Actually, let's start with Romans. I was going to do Egyptians. Let's start with one that we know. Can anyone give me the symbol for any number represented by a Roman numeral? Yes. V. What does that represent?
5.
5. Okay. So let's start with what we know. What's the more basic symbol than that?
I.
Yeah. I represents 1. And very quickly, you'll see in a minute, if you ever saw anything written like this, they're wrong. Because they don't mean what that means, and you'll find out what that means later. It doesn't mean, in fact, what does this mean?
6.
And what does this mean? And you guys all know that, don't you? You don't know it because you understand their rules. You know it because you just were told that's what it was. But we can now figure out the rules, or at least one basic rule. VI, where's the symbol that means the bigger number? First. So V comes first, and then I. So it seems as if, what's a rule we can make then? If a symbol that means a bigger number is before a symbol that means a smaller number, what do we do with the two? Add them. That's why VI. And how do you write 7? You guys remember? VII. 5 plus 1 plus 1. 7. That's insane. What if the smaller number comes first? Subtract them. You guys know how to write 10. X. Do you guys know how to write 9? I appreciate that, but no, that would be 14. IX. If it's before, if the smaller one is before, I subtract. That is a rule you guys don't explicitly know normally. You just memorize what they mean, but now you can tease out, oh, well, that's what the shit the Romans did. That's why VI means 6. That's why IV means 6. That's why IX means 9. How would I write 11? XI. Yes? Okay, I like it. How are you guys doing here? So even if you never knew the subtraction addition rule, you can see how it just goes along with what you've memorized, right? Would you say that this system is easier or harder than our system? Now, it's a little unfair because we know our system. It's not, if I ask you what's harder, metric or what we use, you guys would say metric. And that's wrong, but you'd say that because you don't know metric for the most part. Anybody grew up somewhere that had metric? Basically, I'm asking you, did you grow up somewhere other than the United States? Because we're the only country left. Do you guys know that? That doesn't use metric. I'll stop, because that's coming up later this semester. How do you guys feel so far about Romans? Did anyone know that rule before, or does it, if you didn't, do you see it now? I mean, it's not that big of a deal. Now, there are more rules. There have to be. How do I write 8? Good. V. I. Yes? Not IIX. Correct? In fact, if I write that, isn't that weird? Do you guys agree that looks weird? You've never seen it before because that's not the rule. You're only allowed to subtract one thing. Does that make sense? So I put IIX, that doesn't mean shit, because I'm trying to say two little things in front of a big, that doesn't mean anything, it doesn't make any sense. It should be one little in front of a big to subtract. One other rule is you can never have more than 3 of the same symbol in a row. So let me ask you some bigger things so we can build up to this. Does anyone know how to say 50?
L.
Good, L. So real quick, does anyone watch football? Anyone watch football? Yes, yes. Okay, everybody else is like, you mean soccer? No, I mean, the weird ass American thing we call football. Even if you never watched football, have you ever heard of the Super Bowl? Or the Superb Owl? Yes. Even if you've never watched the damn thing, have you ever watched the commercials? Right, all right. Back in the day, they would use Roman numerals to represent the Super Bowl we were in. Super Bowl 44 had really impressive Roman numerals. We'll talk about how to put that together here in a minute. 43. Okay. But Super Bowl 50, that would have been an L, just kind of dropping from the sky in stone. Are you guys with me? That, not a good look. So that they were like, let's stop with the Roman numerals, guys. So very often we'll use Roman numerals when we're trying to be more like, look at us. Somewhere else we see it is that clock there uses our numerals, but on big ass clocks they use Roman numerals. Why? Because from far away it's easier to see what they are. Believe it or not. Yes. Okay. Anybody know what 100 is? Good, because how many pennies in a dollar? 100, and of course we call them cents, and that comes from Latin centum for 100. It's crazy. Isn't that crazy? So C is 100. Anybody know 500?
Oh.
No. And anyone know 1,000? M. Okay. So, real quick, if I wanted to write, so everybody got that written down? And it's in the book, and it's on the handout, to be honest, the one you already. I'll point it here again. If I wanted to write 300, how would I write that in Roman? This is Hindu Arabic. This is Roman. How would I write 300 in Roman? Say CCC. Yes? How would I write, all right, let's back it up. How would I write 30? XXX. How would I write 40? X. Huh? Oh, okay, you're there. Okay, good. Sorry. Part of me wasn't expecting the right answer, and that's terrible. Because it's weird, but you know it. Now, why can't I do XXXX? I can't have more than 3 of the same symbol in a row. Why? They said so. So you have to go back in time and ask them. That's the rule they set up. Are you with me? So now listen. This is the trippy part. So let me put this in a row. I, V, X, L, C, D, M. Yes? Those are the base numbers. Do you see how that's roughly based on 10 in a way? They're definitely round numbers, yes. Even though they got 5. So they went halfway between 1 and 10, halfway between 10 and 100. You kind of with me? So it's still based on 10, which makes sense because all humans have the capability of having 10 fingers. Some of us don't have 10 fingers, but I'm good. Do you see how I could put an I in front of V, correct? I in front of V makes sense. 4. I in front of X makes sense. 9. That's the last thing. You can only, now this is a little trippy, you can only use a smaller in front of a bigger for the next 2 bigger things. So if I want to write 40, you said it perfectly. 40 is 50 minus 10. Which means I want a 10 in front of a 50. If I put a 10 in front of a 50, that's 40. How we doing? But how would I write, all right, let's see. How would I write 1983? So here's one way to do this kind of problem. Break it down. 1,000 plus 900 plus 80 plus 3. That's what officially is called expanded form of a number, of a numeral. We know that, but we'll just call it number for colloquial use. Then you can identify where subtraction has to come in and where addition has to come in. You guys see that? I can't do 900 as 500 plus 100, 100, 100, 100 because that breaks the more than 3 in a row. So how do I do 900 then? So 1,000 is what? M. 900 has to be 1,000 minus 100. CM. 80 is not too horrible. Because that would be, does addition work? Yes, because then I only need 3 in a row. You can see that? All right. 900. I can't do 500 plus 4 100s because that's more than 3 symbols in a row. So then I change my thought process to subtraction. 80, I could do 50 plus 3 10s because it's only 3 in a row. I don't need subtraction. You guys see how to start to break this kind of problem down? You're going to see problems where I give you Roman, you change it to Hindu Arabic, and I give you Hindu Arabic, and you change it to Roman. We're going to affectionately call Hindu Arabic Ha, H-A. Already did it there. H-A. So keep going. How do I write 80?
L, 2 plus, 3.
Good. And then 3, of course.
3.
Now, has anyone ever watched an old movie from the 80s all the way to the end? Have you ever seen Roman numerals at the very end of the movie? And very often they are MCM, blah, 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 because a lot of movies were made in the 1970s, 80s, 90s. So you're going to see a lot of MCM. Has anyone ever seen this before? You're like, dude, back in the 80s, they didn't have a lot of after credit scenes, so I left, man. No. I'll try to find a video of it for you guys. They still do it as far as I know. Okay. Here's the thing I was talking about earlier about why this does not mean what they think it means. Because if I want to say, how would I say 3,000 again? Or I guess I haven't done that officially. How would I say 3,000? M. Yes? How would I say 4,000? It's okay if you have no idea, because you shouldn't. It can't be M. Why? It breaks the 3 in a row rule, Joe. Okay. So what the shit do we do? There's one symbol I haven't shown you yet, and it explains why whenever you see somebody draw like the lines top and bottom, they're completely wrong. Yes? How do you write the number 4? IV, and if you put a line on it, that line means times 1,000. That's the last symbol we worry about from the Romans. They had ways to represent other things, but this is as much deep as we're going to get. So now you know all the symbols you need to know to represent the Roman numbers we're going to see. Like, for example, we're going to learn Egyptian hieroglyphic numbers. They also have ways to represent fractions. We're not going to go that far. So if that bums you out, you can Google it. It's out there. How you guys doing this? Has anybody ever seen Roman numerals this far? Like gone all the way down? Yes? Okay. Yes. So let me just point out to you, if you have the handout from last time, this guy, on the other side, I've got the Romans here. And I guess you could see the Egyptians, but let's talk about the Egyptians. How do y'all feel about Romans? I normally don't start with Romans, but it's kind of nice because most of us know Roman numerals, IV and VI and blah, blah, blah. Normally nobody knows Egyptian hieroglyphics, and I don't blame you at all. Yes? The only downside is, all right, here's the Egyptians. they had a staff meant 1. So that looks like a 1 to us, but it's a staff. Yes? Let's see how much Jeff remembers. I haven't looked at these in a while. A heel bone meant 10. I'm pretty sure about these 3. A scroll is 100. And I'm pretty sure you should check, Jeff. Do you see a little potted plant? Do you see the way I drew it? It could look different in other situations. All right, let me double check myself. Check myself. So obviously what you're picking up hopefully from this is I'm not going to make you memorize these. Oh, do you? Here. We're going to do... We're going to work on this. Wait, let me give you one down here. Yeah, I was using jellyfish. We're going to work on groups on that later. Okay. You can watch it on the video. Page, what did I say? Page 60, yes. Page 60 in the book, it's got all the Egyptian hieroglyphic numbers. But I'm going to provide those to you on a quiz or a test. Yes? Here we go. Let's see how Jeff did. Hey, I did okay. Staff is 1, heel bone is 10, squirrely dude is 100, and then the lotus flower, they draw it a little different than I do. By the way, if you Google Egyptian hieroglyphic numbers, you'll see different kind of form. They must be a lotus flower, but they might be facing a different way or something. Just like I write the number 4 some way, and some people write it a different way, but we know they're both 4. Yes? Does everybody write the number 2 the same way? No. Trust me, I know. Okay. And then here's the freaky one. Pointing finger is 10,000. Crouching tiger, pointing finger. I can never draw that well. And then, oh yeah, I draw the fish like this, just because it's easier. Fish means 100,000. And my favorite symbol, what's the symbol for a million? If anybody has their book. No? If you won $1 million, would you potentially jump up and down in glee? So astonished person represents 1 million. Which, thinking back to like ancient civilization, if I had 1 million of anything in ancient times, then I'd be astonished. I got 1 million freaking amulets. Oh, holy shit, it's astonishing. Okay. All right, how are we doing? So those are the symbols. Those are the symbols. Now you start to understand it's a lot like learning different languages. One thing is I got to know the alphabet, and then I have to know the rules for putting them together. You know, kind of like the alphabet, the symbols of these, the numerals. How do I put them together? Egyptian numeration system is crazy straightforward, which actually means it sort of sucks in some places. If I want to write the number 124, that's 100 plus 20 plus 4. So how many scrolls do I want? How many squirrely dudes scrolls? I want 1, because that's 100. What do I need for 20? 2 whats?
2
Heel bones. And then I need 4 staffs. That's 124. And if you go to like the, I think I told you this the other day, if you go to the Natural History Museum or one of those museums down at Balboa Park, you'll see the Egyptian slabs, right? And you will see, trust me, this is so cool. You will see those, and you can just be there like, that, my friend, is a 10. Thank you, it's made me like it, I don't care. All right, well, but you'll know, that'll be cool. Yes? Yeah, I know, it's coming. So as long as it was clear that those are grouped, and normally they were like put in their own little chamber, you can orient them however you want to. So they would, one reason why they had like these real life symbols that represented numbers is they could actually tell a story and communicate a number at the same time. If they just reoriented the symbols. Are you guys that all with me? It was a very, obviously Egyptians were very heavy on symbolism relating to their life around them. Right? When I write this number, 20, I don't see it. I can see 20 things. But when I write 2 heel bones, okay, I've 2 heel bones, yes? I can see those.
It would mean it was bad for somebody else, but I could see those. Yes? Okay. You guys with me? So what kind of number would suck? What kind of number would suck to write in Egyptian? Suck. Anybody? Why did 124? Why is that not bad? Because the most I needed of any symbol was 4. So can somebody give me a horrific number to have to write in Egyptian? Yes! Or even better. So 999,999, or 9,999,999. You guys understand? Because then you need 9 of everything. And you're like, just say a million. Just say a billion if they have a billion. And by the way, there are more symbols than what I've shown you. These are just what we're going to focus on. You guys got what I mean? So again, this came first. Do you see how Romans uses symbols, but their symbols are letters? But then they introduced rules that actually made they needed less symbols to represent bigger numbers. So that was an immediate improvement they could make. Even just writing, can you guys go ahead and write 908? Go ahead. You got to get practice drawing these things anyway. The nice thing is every image is distinct, so however you end up drawing it, I should kind of know what you mean. None of them look like the other one. All right. So what does it take to do this? 9 scrolls. They get a little weird at the end. 8 stats. Now here's one, is everybody with me? Here's one advantage they have. How do they write 2 million? How do they write 2 million? Two astonished people. What kind of, he's standing on his head, Jeff. How many symbols do we take to write 2 million? 9 if you count the commas. They take 2. They take 2, baby. Yeah. So they have it over us on that count, but I'd much rather have our system considering 9,000,000. You guys? Okay. So Egyptian's not that bad. Egyptians are kind of fun. I don't know how you feel about it. The little lotus flowers, it really slows me down. I'm like, 7 of these? Okay. God. Okay. They look very wilted by the last one. So we got Egyptian, which is remarkably simple. Very few rules, which means it leads to some kind of horrific outputs. Romans started to put more rules on. You're going to have to memorize the rules. But the rules made it so that they could improve on Egyptian method. They could write bigger numbers with less stuff. These two systems, Romans and Egyptians especially. Can you, Emily, tell me, how do I put a number together? If they give you an Egyptian number, let me do that. Can you translate this back into, everybody have fun with this. Can you translate this back into Hindu Arabic? Sorry. Anybody got that? What you got?
3,164.
Yes. What was the operation you used to get there? True, but what operation? Like addition, multiplication, division? Why did you put a 4 at the end?
because each stick means one, and you had 4 of them, 1 plus 1 plus 1 plus 1. So this is an additive system. Romans are fundamentally an additive system, because what is VI? 5 plus 1, 6, right? Now they had a rule about subtraction, that was just so they could make it quicker to write certain numbers. But it's essentially an additive system. So now we're going to move on to something that's closer to our system. In fact, real quick, guys, go with me for a second. When I write that number, we all know what it means. Can somebody tell me, what does the 1 mean? Did I need a symbol to tell you it was 100? Like, I didn't have to put a scroll there or something, yeah? How did you know that means 100? Because it's in the right place. So this is a place value system. The place it is in tells me what the base value is. The number 2 is in the tens place, so I have 2 tens. Simple? Yes? And this whole thing seems kind of silly, because it's the number system we use. You're like, I've been using these numbers for a long time, Joe. But you have to keep that in mind. What is our number system based on? Every place is based on a power of 10. 10, yes. You guys with me? And I think I told you guys, I mean, obviously there's no way to prove this. But if I could guess why our number system is based on 10, it's because what would we do back in the day? And I've got 10 of these suckers. So of course we're going to have something based on, what did we was doing on 10? Now they start over again in a way, right? Based on 10. So that's why our number system is based on 10. What if we had no pinkies? Don't take the thumbs away, because then we don't evolve. What if I had no pinkies? What do you think our number system would be based on then? 8! We would go 1, 2, 3, 4, 5, 6, 7, 10. Because what's the largest digit in our base 10 system? What's the largest digit in our base 10 system? 9. In fact, how do I represent 10? Is there a single symbol for 10? No. How do I represent 10? 1, 0. Correct? Okay. So everybody semi with me? We're analyzing the hell out of it. And why is it good for you guys to be going through this exercise where you have to understand that really well to understand what we're about to get into, which is the Babylonian number system? Because then you're like, your students know as much about this shit as you do about Babylonians. Well, some of you guys, anybody know the Babylonian number system? You're an interesting person, I gotta tell you. Yeah, I don't know.
I'd say this possible.
Oh, that'll do it. Okay, that'll do it. But before you ever took this class, did anybody know the Babylonian? You knew it even before you took it. Oh, okay. So you still no. Okay. You don't have to know the Babylonian number system. As you learn it, it will reinforce the things about our system that you have to get through to your students. Because they're going to be a blank slate with this stuff, right? Potential, depending on what grade you get. So this literally means, somebody help me out. What place is this? That's crazy. What place is this? Why? Because they multiply by the base. So what place is this? Hundreds, or 10 squared. What place is this? 10 cubed, 11. So how do I piece this back together? 4 times its place value plus 1 times its place value plus 2 times its place value plus 8 times its place value. Now somebody could argue, if a parent saw that, can you see why they would go, why are you making this so hard? It's your problem. Don't be teaching my student this crap. Just tell them what that is. Yes? As a teacher, you understand this is still continued building. You weren't born knowing what this 4, 1, 2, 8 meant. Okay, maybe. Oh, what's up? Oh, those doors are so evil. So here's gonna freak you out a bit. Babylonians are where we stole our concept of how to measure time from. How do we measure time? Yes. 60 seconds in a minute, 60 minutes in an hour. 60 hours don't mean shit, so we kind of gave up eventually. But our number system is based on 10. So everybody with me? Babylonian number system based on 60. What the shit? So let's do this.
that immediately should be concerned, because we have a base 10 system, don't we? So how many digits do I need? How many single digits do I need, including 0? 10. 0? 1 to 9. Once I get to 9, how do I represent the base 2 digits? And then I keep going. You guys with me? So for base 10, I only need 10 single digits, including 0. So for base 60, if they used our digits, how many digits, how many single digits would they need? 60. They need 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What symbol do we use for 9? 9, Jeff. Yes. Do we use a single symbol for 10? Why not? Because our base is 10. I really want, this is so trippy. I need you to get out of what you've lived in your whole life. Realize that our number system is based on choices humans had to make. And now you're going to start to get into choices other humans made. And then that shows you the flexibility. Are you guys with me? You know, like, keep going? Okay. So, Babylonians, base 60, if they did it like we do, they would need a single digit to represent 10. Like they could have, if they had our digits, maybe be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see what I'm saying? Do you understand this isn't shit? Do you understand that doesn't mean 11? That's just me making shit up. Maybe that's what we would have come up with if we had a higher, other than base 10. Anybody, I really want you to. Since we chose base 10, we need it up to 9, single digit, and then 10 can be 2 digits. No ones, 1 10. If our base was bigger than 10, we would have needed more symbols to represent higher numbers. The number 10 is independent from the numeral we use, 1, 0. Has anyone ever done any computer programming, by the way? Any HTML stuff? Okay, I'll show you that later. Yeah. It uses base 16. Identifying what color you want the background on your web page to be. Okay. Now, here's what the Babylonians actually did. Babylonians, are there any Babylonians here? Hopefully this is not, I'm going to call them big, just for short. Because writing Babylonians takes a while. Okay. By the way, real quick, your shirt stripped me out. It's taking me back. I'm the baby. Okay, I'm ready. And that's why I was like, wait a minute, big. Now, the Babylonians only used 2 basic symbols, and there's one more I'll show you. They had a symbol for 1 and a symbol for 10. And that's it. That doesn't seem like enough. Yes? But I'll show you what they did. So the symbol for 1, to be honest, their symbol for 1 was this, which was the end of the chisel they used to write into the tablets. So if you just did 1 chisel mark, that would make that mark. I'm not going to draw a little triangle every time. I'm going to just draw a line, and that's 1. Yes? So the actual symbol looks like this. I'm going to draw this, and that means 1. Then, if they do they turn it into a chisel mark and then a chisel mark. Come here, glasses. So like a chisel mark up a little bit and a chisel mark down a little bit. That would mean 10. I'm going to write that as a less than symbol. Yes? Do you guys see that? Because I'm not going to draw 2 triangles every damn time. So this is 10. That's the only 2 symbols they use. And now, do you guys see what I mean? They chose that symbol to represent what we have to use 2 digits for, yes? Is anybody tripped out? So very basically, how do you think they would write the number 12? This feels a little bit like Egyptian with a lot less symbols to worry about. How do you think they would write the number 12? What do you think? Just give me, it's okay. It's okay to make a mistake now. Huh? Yeah, less than? And then 2. Yeah, that's it. That's 12. What base did I say they use? 60. they stuffed more than one thing in a place. How many things can go in our places? One thing. There's only, I can put a 4 in the hundreds place for it. I can't put a 4 and a 1 in the hundreds place to make it 40 or 100. I can only put one thing. You with me? Is anybody really with me? Is anybody with me? Okay, I'm here. So once I'm over, so how would I write 59? Yes, 5, I call these Pac-Men, but you can call them 5 less than.
And 9.
Holy shit. I lost count, I think that's 9. I'm not good with numbers. Here's what I'll show you, one more symbol. That sucks, yes? That kind of feels like Egyptians. I'll give Babylonians some credit. They came up with a symbol that means minus. So how else could I write 59 if I'm allowed to use minus? What's a nice way to write 59? If I'm 60 minus 1. 60 minus 1. Jeff, what are you doing there? 60 minus 1. I think I got so used to just making them long. So that would be a chisel mark with a chisel mark on top. Yes? That was their symbol for minus. Are you guys all with me? You can use it anytime it makes what you're writing less. But to be really honest, they also did this. So if you never want to use the minus, you don't have to. But there will be some problems that you have to go from Babylonian back to Hindu Arabic, so you better know what that symbol means. But you don't have to use it if you want. Does everybody understand? Does everybody really understand that that is still one place? All of that is in one place. So let's talk about bigger numbers. What the shit did these guys do? So help me out. Our base goes like this, yes? So, what are you doing? Yeah, okay. 1, 10, 10 squared, 10 cubed, yes? So what would the Babylonians look like? Everybody starts with 1 that has a place value system. That makes sense. What would their next place be? 60s. 60 squared. 60 cubed. Okay. That is insane, right? But this is what they chose. What's one reason they chose this is because 60 goes into 360. And for ancient civilizations, what did 360 represent? A year. So agricultural based societies, which is what most early civilizations were. We aren't totally agricultural based anymore, but we rely on it. But they were totally about agriculture. The year was everything. So how the hell do I use this? Does anyone know? Oh, I'm supposed to know. Okay. So if I wanted to write 72 in Babylonian, is that bigger than 60? So I need, I should say, is it bigger than 59? So I need 2 places, yes? Just like if I want to represent the number 13 in our system, that's bigger than 9, I need 2 places. So what I always tell students is, if I'm about to go from us to someone else, identify the places. I need the 1's place, the 60's place. The next one would be 3600. Isn't that too big? I don't even have 100. I don't need this one. So what I try to tell students is, if you're using Babylonian or Mayan, they both have place values. You write the places until you get too big to make sure you went far enough. So 160, 3600 is too big. How many 60s are in 72? 1. 2 60s would be 120. Okay. So how many 60s are in 72? 1. And how many do I have left? 12. So this is my work. I haven't translated fully to Babylonian, correct? It's not a damn thing wrong with using our symbols as you work it out. The last step is convert it back to Babylonian. So I haven't shown you an example of this yet, so let me show you. How would I represent 1? 1. Make some space. How do you represent 12?
Less than
Yes, 1 less than, because that's 10,
and 2.
and 2. you see how they had to make some room? You with me? So that's 160, 12 ones, which makes 72. Maybe? Now, obviously, we're sitting here going, ain't no way I could survive. Like, how would I look at that and just know it's 72? Well, number one, you have to be lucky enough to be educated. Not everybody was educated, but if you were educated, you would be used to that shit. The same way if I said, can you represent 11 decimeters for me in the air? Most of you can't. But if I said, can you represent about 2 inches? Could everybody do that? Could you all do about 2 inches? Yeah, because we grew up in this shit. So if I stare at that, I'm like, I gotta work that out. But if you grew up in it and you were educated, you could just think, oh, 72, okay. Oh, people coming, this many, oh, 72. Yes? Do you guys notice how it's bad, bless you, that they didn't have a symbol for 0 for most of their civilization? What does 0 do for us? 0 does a lot for us. If I want to write 100, if I put a 1, that's 1. What do the zeros do for me? It pushes the 1 to the hundredth place, yes? They didn't have a symbol for 0 at the beginning of their civilization. I think the book shows you the symbol for 0, but for right now, I'm going to pretend like it doesn't exist yet. So if they actually meant, so for example, how would I write, you can do it, Jeff, 3612. What places do I need? I need the ones place, what comes next? 60s, what comes next? 3600, what comes next? 216,000. Just multiply by 60 every time, right? Same thing we would do with base 10. That's too much, so I can stop there. How many 3600s in 3612? 1, yes? And what's left? Huh? 12. So I don't need any of these, but I need 12 of these. So the first part of the civilization, they would have said, one of these, space, space, 12. And they would just sit back and hope that the person who was getting this message understood there was 2 spaces. And the dots I put wouldn't be there. I'm sorry, I should have put those. You guys kind of with me? So the beginning of the civilization, they didn't have 0. 0's main important job is a placeholder, just to push things out to be in the right place. Why didn't the Egyptians need a 0 as a placeholder? Because they didn't have a place value system. If I see an astonished person, it's a million. It doesn't have to be in the millions place. So that's the trade-off when we kind of go to a place value system. How you guys feeling so far? So I need you to see what operations am I using to go from our system to baby. What did I do? What operations? Like up here, how did you get 1? What did you actually do? How many times does 60 go into 72? Yes? You with me? So it's division, and then how did we get 12? What did I start with? 72. If I put a 1 here, how much have I taken care of? 60. What do I have left of the original? 12. What operation is that? Subtraction. So when I'm going from our system to somebody else's, it kind of sucks. We're going to divide and subtract. Can you guys figure out what this number is? Holy shit, look at that. Bees just really went for it. Sorry. Yeah. That's a Babylonian numeral. I want to know what that looks like in Hindu Arabic. Don't say anything, just work it out. You can work it out. Oh yeah, we got time. I think. Let's see. Oh yeah. So if I were you, I would have an intermediate step. What place is this? Ones. 60s. My intermediate step would be just looking at the numerals themselves, right? So what does this symbol represent? Yeah, that's 110 and 1, that's 11. And what's this symbol represent? 12, that's crazy. You guys see what I mean? So there's really two things going on here. There's the symbols in the places, and then there's the places. Yes?
How do we know there wasn't a space there though?
That's exactly the problem. So we're going to have to assume it doesn't look like they kept a lot of space. I'm going to assume that there's nothing in there. So what do you do from here? It's not really surprising what we do, but do you guys see what to do from there? I think they showed. Darn it, did they show you guys? There it is. Okay, good. You show. So what does this mean? What does this mean right here? Yeah, because I have 11 60s and 12 ones, yes. So it kind of makes sense. If I'm going from Hindu Arabic to baby, I'm going to divide and subtract. If I'm going from Babylonian to Hindu Arabic, I'm going to do the opposite. Because I'm going the opposite way. I'm going to multiply and add. Multiplying and adding is always easier than dividing and subtracting. 10 times 60 is 600, so 11 times 60 is one more 60, so 660. Plus 12 is 672. I'm stuck on 72 for some reason. How do you guys feel about that? What is the hardest part about what we just went over? Are the symbols difficult? Can you remember that? I'm going to make you memorize those symbols. I know it's difficult. I'm going to give you the Romans. You got to know the Babylonians. You know 10 and 1. Yes? The actual work, if you just divorce the concept, the work is easy. I'm going to let you use a calculator so you can multiply. You just have to know when to do what. Multiply and add. If you're going one way, divide, subtract, go the other way. What is the most, well, that's kind of a weird question. Most confusing part of this? Can anyone articulate that? No? Yes?
The, division and multiplication.
Oh, so really quickly, if I have this number in our system, it is 2 hundreds plus 3 tens plus 8 ones, yes? That is how every place value system works, period. They could have different bases, like Babylonian's base 60. They could have different symbols that they put on top, the less than in the 1, yes? But at the end of the day, if you're going from their system to ours, you're going to multiply that. Okay. So if I saw a Babylonian number that looked like this, how many places do I have to assume there are there? How many distinct places can you see? 3. So what do you think your first step is? You just told me there's 3 places. So what is each place? Yes, so this one is 1s. This one is 60. No. Times 60 is 60. Times another 60 is 3,600. So if you start at 1, multiply by the base, multiply by the base, multiply by the base, and that's how you build bigger bases. That's exactly what we do. 1 times 10 is 10, times 10 is 100, times 10 is 1,000. And we chose the number 10. Just because we had 10 fingers. So how do I put together what that number is? What's one more step I could take to make it easier to see what to do here? How many are in the 60s place? 13. So let me, above here, I mean 1, 13, and what's this? 20. So how many 3600s do I have? 1. The same way I had 2 hundreds. Here I have 1 3600. How many 60s do I have? 13 60s plus how many ones do I have? 20. Do you guys see that now? Is that better? That's how you can piece it back together. Why don't we have to do any work? Why was it kind of silly? Why were you sitting there going, wow, math boy, blowing my mind. That's 2 times 100. Who knew? Because we grew up in this one. We grew up in this one. You don't have to think like this. You're like, why the hell would you do all that shit, Jeff? To help you explain this is what's actually going on. That's the same thing that has to happen here. Why is this harder? Because thank God we don't have 60 freaking fingers. Yes? That would be a mess. Oh, you're weird as shit. Gloves would be really trippy. I'll be there in 3 hours. You just put them on my 60 fingers. Yes. So what would that be? What's 13 times 60? 780. So I got 3,600 plus 780 plus 20. That's nice. That's 3,600 plus 800, which is 4,400. Okay. So if an educated Babylonian just saw that, they would know it was 4,400. Okay. I never want to play poker with any. I got this like, I'm not going to give this guy a damn thing to work with. You don't know how I feel, John. All right. It's going to take a little getting used to for sure, but there's not like a lot of intense work that goes into this. You have to know the symbols, and you have to know the rules for the thing you're looking at, right? Yes?
Are you or the book going to have a way to like signify the space? I'm still studying with spaces.
Oh, sure. I'm sorry. The Babylonians did come up with the number 0, and we use it. So if I wanted a 0, so like, here's the symbol for 0. I always forget which way it goes. There it is. Okay. That's the symbol for 0. And it's basically just, it really is this. Like a long ass thing, but they just put 2 little triangles. You guys kind of with me? So it's basically the end of the chisel point, just bam, bam, and that meant 0. So if you saw this, 1, this, how many places are there? No. Nope. Of course there's not. How many places have a 0 in them? 1. So how many total places are there? 3. There we go. Now it's a 0 that's in that place. Do you see it? When you see 2 triangles, one on top of another, that means that's a place with nothing. So the first place is, what place is this? The 1s, 60s. So I have 1 3,600, I have no 60s, and I have 10 1s, yes? So that would be 3610. So they did develop a symbol for 0, and then not very long after that, their civilization fell. Thankfully not because they came up with an idea for 0, or else we would have fallen a long time ago. It's just bad coincidence. I like to joke around. This one guy's like, hey guys, look at... Shit, we're done. That one was just for me. I'm okay with that. All right. How about this? Let's get freakier here. How would I go back from our system to Babylonian? So let's say I want to do 257. I want to convert that to Babylonian. We do the same thing we did. Well, let's see. How do I determine how many places I need? I think I did a simpler example of this earlier, but I can't remember now. Do I need a 1s place?
Yeah.
I always need a 1s place. What's the next place up that I could use? 60s. What's the next place up? 60 squared, so 3,600. Do I need this much? No, because this is bigger than what I even have. So does anyone remember, we actually did this earlier, now it's coming back to me. How do I figure out how many 60s I need? Well, sort of, I mean, you can think backwards, but you divide. But you can think of it as multiplication, because 60 times what is close to 257, or you can divide 257 by 60, right? Does anyone know what that is? How do you get close to 257? How do you get close to 25? How many sixes? 4. So you need 4 60s to get close to 257, yeah? So I need 4 of these. How much do I have left? 17. So then I need 17 of these. One's place is just kind of like the junk pile at the end. Whatever's left, just throw them in there. What would tell me I made a mistake? If I put a number like what here? You guys understand my question? There's something that would tell you you made a mistake.
61.
Yeah, if I put a 60, anything 60 or above in that place would mean I made a mistake. If a student said, my sister just turned 2010, and you're like, do you mean 30? Do you see what the student did? 27, 28, 29, 2010, right? You understand what I'm saying? Could a little person make a mistake? Has a little person? Have I personally heard a little person make a mistake? Yes. Yes? All right. So if I end up with like 63, all that means is there's 160 you didn't take account. So that I would just boost this one up by 1. Do you see that? It's good to know why you made a mistake. Like, how can I tell I made a mistake, and then how do I correct for it? And then I just have to do what? How do I represent 4? How do I represent 4? And baby? 4 ones. And how do I represent 17?
Less than 7.
Yeah, you could do less than and 7 ones. Or you could do 2 less thans minus 3 ones, yes? Either way, right? Let me put that in parentheses. So now somebody's going to be like, what does parentheses mean in Babylonian? No, it's just both of those would be right. And in fact, again, Babylonians would actually use either one, to be honest. So you need to look at this as like a little puzzle, right? We don't live in ancient Babylonian times, so we don't have to know this to live, but it's sort of a puzzle to put together. Yes?
Do we have to use these symbols for the test, or are we going to use the actual Babylonian symbols? Like, I know you said you would bring this symbol.
Oh, no, you guys can do the same way I am. It would be a little silly to have to draw like little triangles for each side of the symbol. It doesn't really help. It doesn't really illuminate anything. It just adds a little extra work to you. Does that make sense? If I actually gave you all clay tablets and a chisel, then it would just be that way. The end of the chisel they used was shaped like a triangle. You with me? So if you did it, it would look like a triangle, but when we're just trying to do the work and represent the answer, we all know that it's not really this. But we can use this just to make it quicker. All right. Yeah. Considering what time it is, I'm going to talk about the Mayans, and then I've got, this kind of sucks. Let me just show you how I do these group work things. So next time, there's going to be a puppy group, fish group, bird group, ladybug group, watermelon group, palm tree group, and a jellyfish group. And then it repeats. You with me? So this is one way to kind of like make groups really quickly. Is just pass it out and then have people find their groups. Very quick, funny thing. Last 2 semesters ago, I made some for Halloween. So I had like a witch, and a cauldron, and a skeleton, and then I had a witch's broom. And this became kind of like a big thing. This one girl, she was in the broom, and she says, "Really, you put like a broom?" So then the next time I just made everybody in one group, and I put like a normal broom. So we were all in the broom group together next time. Anyway, I just had a lot of fun with that. So let's talk about Mayans. And then I promise you on Thursday, I'm going to show you some videos of little ones. And we're going to do this group work. Okay. So here's what the Mayans did. Mayans used an almost base 20. Sounds a little weird, but what number did we discuss earlier that a lot of ancient civilizations kind of revered because they were agricultural societies? 360, because that was roughly how long a year is, 360 days. So the Mayans almost used base 20. Here's something else you're going to love about the Mayans. They didn't write their numbers like this, they wrote their numbers like this. Not like this, up and down, yes? Lowest base, and then you build on top of that. So let's start with their numerals first. Are there any Mayans here? No, okay. I always want to ask it's almost a funny question, but there are Mayans still on. They didn't all go with the aliens, right? Some of them stay behind. No, I don't really believe that. But who knows? They used blueberries and pancakes. Or at least that's how I see them. So if I wanted to write, for example, the number 12, what is that made of? How many pancakes would I need? 2 pancakes, and then how many blueberries? 2 blueberries. So now you start to see why I call these pancakes and blueberries. If you don't like blueberries, they could be chocolate chips, they could be raspberries, they could be whatever the hell. If you don't like pancakes, they could be records, I don't care. So that's a single place. Okay. So that's in the ones place currently. So that's it. That's their symbols. Oh, they had one more. They did start off with, because of course they got help from the aliens. Well, this book draws it differently than I was taught. Oh, that's right. I always forget that. This book draws it like this, which is not the way I was taught, but it's okay. This is the symbol for 0. It's like a bread loaf, yes? So, what does their places look like? Their places, they start with the ones place, and not surprisingly, they go to the 20s place. But what would the next place be if it was a truly base 20 system? What would the next place be? 1s, 20s, 400s. Are there 400 days in the year? No. It's closer to 360. So we all live with this now because of a decision they made. They decided it's always base 20. You always multiply by 20, except for this one time you multiply by 18. Because what's 18 times 20? 360. What's 36 times 2? So 360 times 20 is 7,200. And then you keep going. You guys kind of with me? So it's a little trippy. Theirs were like this. Sort of like ancient Chinese numerals were also like this, yes? So theirs go up and down. So let me show you Mayan numeral. We're going to convert it to a ha. Ha. So let's say I've got that, yes, and then I've got this, and then I've got this. Can you see how many places there are? 3 places. We know they have a symbol for 0, so if we don't see it, we know how to count. And if there were really less places, the blueberry should have been in a line. So I know there's 3 distinct places there, yes? Do you guys see that? What is each place? What's the bottom place? 1s, then there's the 20s, and then there's the 360s, because they're crazy. And of course, what does this symbol here mean? 1, this one, 2, this one, 4. 3 pancakes, so 3 5s, and 4 blueberries, so 19. So I have, are you guys with me? Every place value system, what are the places? How much is in each place? Multiply and add, yes? I have 1 360 plus 2 20s plus 19 1s. So that would be 360 plus 40 is 400 plus 19. 419. Just one shy. Okay. Trippy, but nifty. And the Mayans, these were their everyday numerals. I think I told you last time that if you go to Chipotle on the walls, you can see Mayan art, and some of those are actually like their formal way of representing one-digit numbers. So they're gods. One was 1, one was 2, one was 3, all the gods. Yes. I don't think everything in Chipotle on the walls is related to Mayan numerals, but some of them aren't. It kind of trips me up. Because I think the owners are descendants of the Mayans, if I remember correctly, or something. The people that set it up. Or they just like Mayan stuff. Okay. So I'm really sorry. Today was a lot of me talking. Next time, videos, group work, and then we'll finish up chapter 2. When is our first quiz? A week from today. And what is it on? 2-1-2-2. Cool. Okay. So come ready with questions next time.